unauthorized JavaScript. And the thing is, I think that asset server security is often a little bit underestimated. So as soon as an attacker has the ability to alter your JavaScript's content, they can basically do anything. Maybe, for example, stage login pages under your domain and then wait for the user to enter the passwords, or they can also do all the AJAX requests that you can do and then send the informations to their server, or yeah, stuff like that. And I really hope we'll never see the day where somebody gets access to the Google Analytics JavaScript servers or the Facebook like button JavaScript servers, because this stuff runs basically everywhere on the world, on hundreds and millions of websites. Yeah, but there's also a way to mitigate that, at least for stuff that you've built yourself or for libraries that don't change too often. And this is, instead of just embedding a script source tag, you also add an integrity attribute, which includes a content hash of your JavaScript file. And this basically tells the browser, so okay, download the JavaScript, and if the content of the JavaScript doesn't match this hash, or the hashed content of the JavaScript doesn't match this hash, then please do not execute it, and then you're safe. The site will be broken, but at least nobody will get hurt. And the cool thing about this is that it's 100% backwards compatible. So for browsers that do not support the integrity attribute, they will just download and execute the JavaScript as it used to be. So now that we've made pages a little bit more secure, let's make them a little bit faster too. And this is how to really cache assets. So you might think that once you have a cache control max age header, which is maybe for a year, that the browser will always serve that file out of its cache until the cache expires. And I just want to point out that this is not true by default, and we'll also show a way how to actually achieve this. And I want to do this by an example. This is a web page with a bunch of images. Let's pretend it's 40 maybe, or 50. And those are your images, and you are pretty sure that they will never change, or at least not in a year. And if they change, you can just change the URL and then bust all caches, which is more safe anyway. And I would like to go through what actually happens if the browser requests in one of those images for the first time and then for the second time, and then explain the problem. So what happens is the browser requests the image, and your server will basically answer with 200 OK, because the image is found and fine. Then there's the image content, of course, but there are headers in between, and there's, for example, the cache control header with the max age. This is 1 year in seconds. And an e-tag, which is the content hash of your image. And then the browser will cache this image in its cache. Yeah, will store it in its cache. And then whenever you navigate through the page, will deliver it from its cache. But when you do a reload, which actually happens more often than you might think, then it won't serve it directly from the cache, but will initiate a request to your server. Although you specified before that the image will be fine for a year. It's a so-called conditional request, and the browser will add a if non-match tag, header in this case, with the hash, the e-tag you have provided before, and will basically ask your backend server if the image is still matches this hash. And this is the case because you are sure that this will be the case for the next year, and therefore the browser answers with a 304 not modified response, omitting the header, omitting the body, so the body has not to be transferred again, but you still have to make the request with a lot of latency. And if you have 40 images, this is done for 40 images. And if you are talking about a scale like Facebook, then this will result into millions and millions of unnecessary requests. And Mozilla pioneered something that is going to fix this, which is called cache control immutable. And with cache control immutable, which is a HTTP header, you can tell the browser to, like, I am really sure that this image will not change in the year. And this is how the request then looks like. So the first request to the image is, again, the GET request, and you will receive the image content again. But this time, the cache control, in addition to the max age, also has an immutable flag. And when the browser or the user refreshes the page the next time, then the browser will simply serve it from its cache and not ask you ever again, at least for this year. And I guess this is pretty cool. The issue is now if you go to Chrome and want to try this, then you will have a bad time because they were asked to implement this as well, and then they just omitted the entire conditional requests, and you don't need the header there. It just works out of the box now, which is cool as well. So now we improved caching a bit, but no matter how good your caching might be, there is always a first uncached request to be made to a website. And this is why I would like to talk about resource hints, and especially the preload resource hint. My example is a totally awesome website, which is a blog post about dancing pedestrians, and with a large hero image, which I would consider pretty important for this page. So yeah, this is how it looks like. This is maybe how the head looks like. So there's the style sheet, the style CSS, and a bunch of JavaScript files. Nothing too uncommon, I'd say. This is the CSS, so there's only the background image for the dancing pedestrian image. The issue is when the user is on a slow network, this is how it probably will look like when they open the page. So I'm gonna wait for the image, and then it's gonna take a while until it appears, and this sucks in this case because the image is super important. And you can also see it in this waterfall graph. I hope you can see it. Should be fine. That the image is the last item, and it is only downloaded after all these scripts and the CSS. And this is because if you specify a background image in CSS, it will only be downloaded if the selector matches, and your browser can only know if the selector matches if it has downloaded and parsed the CSS entirely, and also the scripts, the synchronous scripts that follow it. So this is why the image download starts at the very end. What you can do is you can add a link tag to your head. It's in this case above the style sheet with relations set to preload, and the href is your background image. And this tells the browser that you want this asset to be downloaded as fast as possibly, as fast as it can. And so you don't need to wait until it finds it in the style sheet. And the resulting waterfall chart looks like this. So the background image is now downloaded in parallel with all the other assets, and the user will see it much earlier than before. And you can use it for other things as well, for JavaScript that you will load asynchronously, or C is for asynchronous CSS loading too. So, but if that's still not enough, and you really want those, there's actually a way to tell the browser even earlier about resources that you might need. Enter early hints. So this one is a request for comment that isn't implemented in any browser yet, I guess, but I think it's so cool I wanted to mention it anyway. But before I will dive into that, there's one thing I'd like to emphasize, that is that in HTTP, one request doesn't necessarily result in only one response, and the spec states a client must be prepared to accept one or more status responses prior to a regular response. Also, I'd like to give an example of something that has been in place for years already, to give a better understanding, which is the status code 100 continue. So imagine you are a YouTuber and you want to upload a large 8 GB video to YouTube, but you're not sure if you're allowed to. So if you're still logged in, what you could do is simply send the 8 GB of video along with your request and then get rejected and have congested the network. But what you can also do is send your cookie information and the content length that the video will have, but not send the body right away. And then also the expect 100 continue header, which basically tells the server that you will not send the video right away, but expect its response. So, and if then the server will check if you are still logged in and allowed to upload the video, and if that's the case, we'll answer with 100, and only then you will go on uploading the video, which will then result in an HTTP code of 200 or 201, depending on the implementation, or something 400 if it failed. And this same mechanism is used in the 103 early hints. So when you make the request to the server, then the backend server can generate your HTML by talking to APIs or contacting the database for information. But while the server is added, the web server can already give you the response with the resources that you will need once the page is done generated. That you will need when the page is generated. So, and once this happens, the image will already have started downloading and will be there even further, even faster, which is pretty cool. And the last thing I'd like to talk about is at event listener, or better yet, the third parameter of at event listener. So who of you has seen that before? Oh, quite a few. Cool. So what it basically changes the propagation model, or how the DOM events flow. So if you set it to false or don't set it at all, then events flow basically like this. Look at my awesome Google drawing skills there. So when you click on the target, then the click target event handlers will be called first, and then the event will basically bubble up or flow up through all the ancestors, and the event handlers there will be called. Then that's the default nowadays. Then there's if you set it to true, then it changes to something called capturing, and this basically reverses the way events flow. So the ancestors will get the events first, and the inner target, the click target itself, will receive the event at last. So that even allows outer containers to cancel the event before it even arrives at the click target. And you might now ask yourself, why are two in place? I guess it's just for historical reasons. There were two teams that came up with different solutions for the same problem, and now we have both, basically. But we are settled for bubbling as default. But this parameter actually has changed in the last year, I'd say. So it's not a Boolean anymore. It has now become an object, which allows us to configure even more event handler options. So the first one, which is still in place, of course, is capturing, because it was there before, so it still needs to be supported. But there are also two new ones, which I would like to talk about briefly. The first one being once. So if you set once to true, then when your event handler is being called, then it will be removed automatically for you. So it will only be called once, as the parameter already says. And this saves us from writing a lot of boilerplate, or using jQuery, for that matter. And then another one is a little bit more interesting, I'd say, which is passive. And so there's one problem with mobile phones. So have you ever tried scrolling a web page? This is often pretty janky, and this is because when you scroll and use, for example, then you are, as a developer, able to prevent this touch move from happening, which is good on the one side because it allows to be flexible, but it's also bad because browsers need to wait until all touch move event handlers are done with their work before they can actually paint a scroll, because you could cancel it and then the browser wouldn't be allowed to scroll. And with passive, if you pass passive true, then you are promising the browser that you will never ever call prevent default in your callback, in your event handler, and that allows the browser to just paint a scrolling, and you still can call prevent default, but it won't do anything because you promised that you won't. One last thing is, if you want to use the new version, so the object version instead of the bool version, you need to feature detect it first, because imagine you're using something like this in an unsupported browser. Then you're giving the option object with capture false, but what you're actually getting is capture true, because this is an object, and in JavaScript objects are truthy, and therefore use capture is true, and then you're in for a surprise. And the last thing I'd like to show is how to feature detect, or basically a quick and dirty way how to do it. And I want to show it because it involves something I've mentioned earlier, which is getter listening. So what you can do is just add an event listener to any event. It doesn't ever have to be called at all. and then you use capture, but use the getter syntax of capture. And if the browser supports the object version, it will ask the object if capture is true or false to read it and use it. And if that's the case, then you know it got called and know that it's supported or not. I hope that makes sense. Yeah, that's basically it already. So thank you very much. If you still have questions, then don't hesitate. We've got still 8 minutes or so.